Welcome. In this video, we begin our second lecture in the Introduction to SQL series. In our previous video, we introduced the SQL select statement, and we also addressed the concept of data retrieval by specifying a predicate. The predicates that we used in those examples were all very simple, involving just one condition against one column. What we're going to do now is expand on our view of conditional retrieval by introducing what we refer to as a complex predicate or compound predicate. We'll take the basic principle of the predicate that we saw in the first lecture and combine multiple simple predicates into a complex predicate. Again, we'll continue our examples using only a single database table. Because a database usually stores large quantities of data, applying only a single search condition will still result in a large number of rows in the query output. In this lecture, the predicate concept is extended to include multiple conditions. So we'll be showing how simple conditions, such as those seen in the queries from the previous lecture, can be combined to express more complex conditions that must be satisfied by a row in the target table. So the objectives of the lecture focus on explaining how multiple conditions or predicates can be combined to form complex predicates. To achieve this, we'll introduce the Boolean operators. This actually should not be an introduction to these operators, but should be reviewed to you based upon your experience in programming languages. So we'll talk about AND, which is used to combine simple predicates using what is referred to as conjunction, or combine simple predicates with disjunction. And finally, NOT will take a predicate and negate it, the concept of negation. We'll explain how complex predicates that involve a combination of these operators, not, and or, will be evaluated by the system. We'll also show how to alter the default order of evaluation by using parentheses. And finally, we'll discuss a couple of special operators available within SQL. First is in, which is kind of an iterator, and between. Both of these are not absolutely necessary within the language, but can be thought of as kind of convenience operators. Let's look at the motivation for the Boolean operators. We note that unless a primary key or a unique value is provided in a where clause condition, retrieving rows based on just a single condition is usually going to result in a lot of data, far more than what the user probably wants to take a look at to come up with an answer to a business question. In practice, multiple search conditions must be used to precisely identify only the data that is relevant to answering a particular question. SQL allows the multiple conditions to be specified in the where clause that we discussed in our previous lecture. What we'll do is take the simple conditions and combine them using the Boolean operators that we've addressed. And we'll also talk about negation to kind of get the opposite effect of a condition. So note that the term used here of single search condition is synonymous with simple predicate. So in this lecture, the notion of a complex predicate is what we'll be introducing. So regardless of whether the predicate is simple or complex, the where clause is still evaluated and ultimately produces a true or a false, which determines whether a particular row will be returned and included in the query result. Let's begin with AND. This query serves the purpose of identifying those courses that satisfy two conditions. They are sponsored by the computer science department, and they also have a lab fee of 0. So notice there are two simple predicates, lab fee equal to 0, and the other predicate, department, is equal to CIS. The AND keyword is placed between the two selection conditions within the where clause. The order in which the conditions are specified should have no effect on the performance of the query and will not change the question being asked. Thus, we'll get the same answer whether we say lab fee equal to 0 first and C department equal to CIS second, or if we change the order. So the intent of a query containing the AND operator is to retrieve a row if and only if both conditions are satisfied. In practice, a table will likely contain rows which match just one condition or the other condition, but not both. Thus, a query that has two conditions combined with AND should produce a smaller result table. Let's take a look at this in a bit more detail by examining the course table and the two predicates involved in this query. I've created my tables by running the academic.sql script, so we're ready to examine the course table. The two predicates that we're using in our current query say that the lab fee is equal to 0 and the department is equal to CIS. You can see here that I have 6 rows where the department is CIS. If I scroll through the result, there are no additional rows. So C department equal to CIS will produce 6 rows. But what about lab fee equal to 0? There are 2 such rows shown here. We can see C33 and C44. They each have a lab fee equal to 0. If we scroll through the result, what we'll see is 2 additional rows. We'll see P44 has a lab fee of 0, and T33 also has a lab fee of 0. When we combine our 2 predicates, and we say, let's select from course where the lab fee is equal to 0 and the department is equal to CIS, we'll get the intersection of those 2 subsets. And it turns out that only 2 rows satisfy both conditions. So of the 6 rows where the department is CIS, only 2 of those rows have a lab fee of 0. Put another way, of the 4 rows where the lab fee is 0, only 2 of those rows have a department equal to CIS. Given the current content of the course table, there are only 2 rows that satisfy both conditions. A query that includes multiple predicates can test conditions against different columns, or as we're showing here, we can test multiple conditions involving the same column. In this example, we're looking for 2 conditions to be satisfied because we're connecting the predicates using AND. First, the lab fee of a course must be greater than 0. The second condition says that the lab fee must also be less than 100. Note that although we're using the same column in both conditions, the column name must be specified in both cases. Remember that the syntax of a simple condition or predicate essentially takes the form of column, relational operator, and expression. And when we combine 2 predicates, each simple predicate must adhere to this syntax. We also want to mention that it's possible to connect more conditions than just 2, as we've shown in our current examples. For all practical purposes, there's no limit on the number of conditions which can be used in a where clause. Let's consider the following query, which actually connects 4 conditions together with AND. Each of the individual conditions must evaluate to true in order for the where clause to take a true value and cause a row to be included in the result set. Our next query returns rows for courses that are sponsored by either the CIS department or the philosophy department. We have two separate conditions. C department could be equal to CIS. C department could be equal to philosophy. We connect these conditions using the OR keyword. Note, just like AND, it is placed between the two selection conditions. Assuming that two conditions are connected by OR, a given row will be selected if it matches either one of the conditions or both of the specified conditions. However, in this particular query, it's impossible for a row to match both conditions, and that's because a course must be sponsored by one department. As in our last example for the AND operator, we are again testing the same column. So we have to formulate well-formed predicates. Note also that the order of the predicates is not significant. It will have no effect on the query result or the performance of the query. To demonstrate the inclusive nature of OR, our next query uses predicates that involve two different columns. This query will display any row which has a lab fee value of 0 or a C department value of CIS. Because two different columns are being examined, it is possible for any row to satisfy both conditions. This is in contrast to our previous example. So we say that OR is inclusive, and this means that a row is selected under the special case where it matches both of the specified conditions. This is in contrast to what is called an exclusive OR. Note that it's possible for a query to have more than two conditions connected with OR, just as we saw with AND. Consider the following query that uses 4 conditions connected by OR. In this case, a row will be selected if it matches any one of the specified conditions. In our previous queries, we identified the rows that we wanted to include in the result set. It's also possible to express a condition that says these are the rows that I do not want. In this case, we can think of talking about the complement of a set. For example, in our rectangle here, this would represent our universe of discourse. This would be all of the courses offered by the school. But within the rectangle, there's a subset that we've identified as the CIS courses. If we were to say where C department equals CIS, we would be extracting that subset. If we say those are the rows I don't want, then we would get every row identified by the shaded area in the rectangle. This is accomplished by using the not keyword to precede the predicate. This example returns the courses that are not sponsored by the CIS department. We use the predicate C department equals CIS to identify rows that are not of interest to us, and we inform the system to exclude these rows by preceding the predicate with the not keyword. Note that specifying not can be thought of as allowing you to indicate those rows which you do not want to include in the result. The not keyword must be placed before the predicate, before the conditional expression, following the syntax that we show here. As an alternative to the not keyword, the negative relational operator of not equal could be used. The following queries use a negative relational operator in place of the not keyword. They are logically equivalent to what we've expressed here using the not keyword. We've discussed each of the Boolean operators individually. We now want to consider what happens when you have a complex expression that involves more than one Boolean operator. the system will be required to decide on some order of evaluation. If the where clause does not contain any parentheses, the system will follow a specific sequence. We refer to this as the hierarchy of the operators, or operator precedence. Not will be evaluated first, and is evaluated next, and finally, or will be evaluated. In this next query, we're looking for any 6-credit theology course or any course that has a lab fee of 0, regardless of the sponsoring department and the number of credits. In this query, a given row will be selected if it meets either or both of the following conditions. Department equals theology and lab fee is equal to 0. And the second condition is credit is equal to 6. Due to the operator precedence, C department equals theology, lab fee equals 0, are bound together because they are connected with and. Then credit equals 6 is connected using or, making it independent of the other conditions. Compare the current query to this alternative query. This alternative uses the same individual predicates, but they are connected in a different way. Due to the operator precedence, these two queries are not logically equivalent. In our next query, we have two conditions connected with or. These conditions are enclosed within parentheses, causing the system to alter the order of evaluation. The parentheses are going to cause the or to be evaluated before the and. So a given row is selected if it meets both of the following conditions. Department is equal to theology, and the complex condition that involves lab fee being equal to 0 or credit being equal to 6. Thus, this query will produce a result with courses from only the theology department. Note that this query could have been written without the use of parentheses, but the parentheses serve not only in this case to alter the order of evaluation, but perhaps to enhance the readability or clarity of the objective of the query. This next query involves all three of the Boolean operators, but it does not use parentheses. The absence of parentheses requires that you understand the operator precedence in order to determine what this query is going to accomplish. Note that it's considered a good practice to include parentheses to avoid confusion and misunderstanding of a complex predicate. This query could be rewritten with parentheses by enclosing the first condition to emphasize that we want the system to evaluate the not condition first. In this case, the parentheses serve to make explicit the order of evaluation. This may help to avoid logical errors, or what we might call an almost correct SQL query. The following query provides an interesting example of negation. In writing the query, we start with a condition to identify the rows that we do not want. C department equals CIS and lab fee equals 0. We then precede this complex expression with the word not. The parentheses are needed to group these two simple conditions together and override the precedence of not versus and. An equivalent expression can be achieved without using parentheses. This is an example of De Morgan's laws. With the following query, we introduce a special operator called in. The in keyword provides a convenient way to identify a row to be retrieved from a table by indicating the name of the column whose value will be inspected and a set of values. Any value within the set can be present within the specified column, and the row will be retrieved. The set of values must be enclosed within parentheses, and the values are comma separated. If the values are character data, then the values must be enclosed with apostrophes. Numeric literals are, as shown in the example, not enclosed within apostrophes. Note that the in keyword or the in list operator is redundant. We don't actually need this operation. It's a convenience operation. For example, consider the following equivalent query that will return rows for 2 credit, 6 credit, and 9 credit courses, but we don't use the in keyword. It is possible to apply negation to a predicate that uses the in keyword. Simply place the not keyword before the predicate, and we've achieved negation. When using a predicate with the in keyword, it is also possible to insert the word not after the name of the column and before the in keyword. Here's a query that uses negation with the in operator. Let's take a look at the actual result of this query. Our predicate indicated that courses sponsored by theology, as well as courses sponsored by CIS, should not be included in the results set. That left only philosophy department courses when we consider the current content of the course table. And that's exactly what the query produced. Another special operator provided by SQL is between. We use between to specify a range of values for a column. A row will be selected if the specified column has a value within this range, and this is an inclusive range. The column's value is always compared as greater than or equal to the first value that we specify, and less than or equal to the second value that we specify. Like the in keyword, between is redundant. An equivalent where clause can always be written using an and connector. Not can also be used with an expression that involves between. In this case, it's used to select rows where a given column value falls outside of a specified range. By saying not between, we achieve the negation of the result that would be produced by using between. Examine the following query. Consider what the result set would contain if you were to run this query. You might want to pause the video for a moment and think about it before moving ahead. To summarize the select statement thus far, we note that the general format of a typical select statement involves retrieving only some columns and some rows, and then possibly imposing an order on the rows contained within the result set. The where clause may be complex and include many simple conditions combined with the Boolean operators. The order by clause is always listed as the last clause of a query. The order by may identify one or more columns. If these columns are present in the results set, they do not have to appear in the same left to right order in the select and order by clauses. Having now completed 2 lectures on basic SQL data retrieval, you should now be comfortable with the notion of retrieving data from a single database table. In our next lecture, we'll consider how to perform an analysis of data that has been stored in a database table. We'll be examining aggregate functions and grouping operations. Although the lecture will present some very exciting material, we encourage you to ensure that you're comfortable with the material we presented in these first couple of lectures before moving ahead. I look forward to presenting this more advanced material to you. See you soon.